Hello, I'd like to show you the solution to this puzzle in the game Prime Mover. This is the final puzzle. It is one of the most interesting and challenging puzzles about engineering that I have ever solved, and I spent on it maybe a week or a couple of days, but I finally managed to solve it. This is a processor puzzle. The task is just wild. It is very difficult to comprehend, but basically what this thing wants from you is it wants you to make a central processing unit, like the processor, like the one that's in your computer, the square little thing, silver thing, that it can take instructions from up, left and right, and it will calculate some value based on these instructions. So let's look how I did it. Here you can see all of the streams of instructions are being merged into one stream. I've done it because this way it is a lot easier to send numbers to places you want to send them, because the space is limited and you really want to not worry about squeezing numbers through tight corridors. Okay, let's this one should be a bit more optimized. Come on, this is normal, by the way. It always does that. There are a lot of chips in this puzzle and the game just can't handle that amount. Here we go. I decided to optimize it a little bit here. So, same story, numbers merge into one stream. Then, this is like the main processor. There are 4 main components in here. This one is memory, like the ROM memory, or you can say EEPROM memory. This one is RAM. This is the RAM module, random access memory. This is algorithmic logic unit, or ALU, or calculator, however you want to call it. Basically it adds or subtracts two numbers together. And this is the ROM, EEPROM, and this is program counter or clock, whatever you want to call it. Let me quickly just draw this for. This is ROM. This is RAM. This is algorithmic logic unit. And this is a program counter. So basically how it looks like. First of all, we take the first instruction. No, we initialize the program counter, we send a random number into it, and it outputs 0. Give me the first instructions. It tells the ROM to give it the first set of instructions, A, B, and C. 3 numbers. Then it takes this A, B, and C, and it sends them everywhere. It sends them to the RAM, it sends them to algorithmic logic unit, and it sends them to program counter. No matter what type of instruction there is, it sends it everywhere. And then it decides in every place in the RAM, in the algorithmic logic unit, in the program counter, is this instruction important? Should this model execute this instruction? Let's see how it works. Always happens. No, we lost it. Let's try again, so that you can see it. First of all, everything is being loaded into RAM. Then it sends A, then it sends this is C, I think, and this is B. It sent B. All of these numbers, all three went into the program counter, then they will all travel to the RAM and to algorithmic logic unit and to the output, because there is like the fifth instructions that tells to send a number to the output, so we need to send an instruction to the output as well. This random access memory is basically the solution to one of the previous puzzles. I will show you if you want it. Well, I can't know if you want it, but I will show you it anyway. That's what I meant. And the first instruction to this program is set value 5 into memory cell 1, and as you can see it's blue, it means there is something in there. The second instruction of the program is set the number into second cell, and the third instruction is the same, and if we pause we can see that there is indeed number 5 in here, there is some number in here, 1 in here, and 0 in here. So this is just the same random access model from the previous puzzle, and it works. Now the next instruction, it will ask to add two numbers, like this third instruction or whatever, and it will send an output. Also, this instruction, it says that it needs to add, I think this the first one, subtract B to C, subtract the value that is in the cell B from the value that is in the cell C and put it back into cell C. Very complex instruction. But as you can see, we send numbers into the output, into the clock, into the RAM. We send the output everywhere. And this is done as well to save some space, because we only have four output or input lines coming out of every module, so it would be very difficult to only send numbers where we need them. That's why I send them everywhere, and only then later decide whether I need them or not. Like for example, here's the gate is closed. Like if the number will come through here, it will end up on this cross. Yes, and it closed the gate. But if we get some instruction that, for example, says this, like the sixth instruction, it will come through here and open the gate, and then we will use the number that we sent. And this is used basically everywhere. It's used in the output. Again, the gate is locked, and if we receive a specific instruction that requires this number, the gate will open, and then we will use this number. It's done everywhere. It saves a lot of time. So, and like this is it, how this program works in a nutshell. Program the solution, and it will again send everywhere, and yeah, that's how it works. And it takes quite a while to run the solution. It takes 69,000 ticks. Very nice, I'd say. What else can I say? Well, I guess I can show you how this ROM works. Basically, there are three like ROM modules: one for A, one for B, and one for C. They all look absolutely the same. They all get merged and sent up just as we send them, and this is how we split them into three. Or three three numbers come in, and one comes out on the left, one on the top, and one on the right. and in very specific order. The order doesn't get mixed, it's always consistent, so it's a very nice system. I think we solved the first set of inputs, and if we look into this model, it is a recursive model. It's basically the same model multiple times, and that's how I can store 15 instructions, or I can even store as much as I want, because I can always just add another model. And this is the last model, and there is just an X in here. Well, I honestly have no idea how can I explain this solution better, because it's so complex. There is so much going on, and I can't cover everything. All I can say is that the general principle is merge 3 inputs into one, and then split them at each component. Then, based on the instruction, decide what to do with these numbers. Delete them or use them somehow. Yes. This is the general principle. And every single one of this component is being used in some previous puzzle. The RAM model was used in the previous puzzle. Addition and subtractions were in previous puzzles. Gates that close or open, I think that's a transistor, have been used in previous puzzles. All of these have been used in previous puzzles. The challenge in here is to wire it all together, and it was, I think it was very, very fun to do. Well, I wouldn't say that it was fun. It was extremely difficult and frustrating at times, but I did it, and I'm quite proud of it. And that's it. 69. I don't know who this guy is, but sorry, I guess. I think that's a nice result. All of the people in here like this first column. I'm a bit disappointed how easy it is to cheese this puzzle, how you can just brute force all of the inputs, just take the first input, throw away every other input, and then just generate the solution based on the input. It's quite sad that so many people did that, but I guess that things like that will happen. About the memory model, the same one that was used there. How it works? Basically, from the top comes in an address, from the right comes in the value that you want to set, and from the bottom comes in the instruction, like 1, 0, or -1. Reset the memory, set something, get something from memory, or set something to the memory, and based on what number is there, it sends. It can go left, it can go right, and it can go up, and it can send the address, or it cannot send the address. It can send the value, or it cannot send the value. Basically, when it's 0, we don't need to send anything. We just need to get something from the memory. And here what happens is we take an instruction, we split it into 3, I couldn't fit it in here, and now that I think about it, I maybe could have, no, doesn't matter, stop optimizing, and it sends the instruction to every single element, and it takes the address and it sends it into every single element, and the value also sends it in every single element. All of these are the same, and let's see where happens what. Wow, I optimized it quite a lot. No, I'd like to see. Okay. Basically, this is our memory cell. It can take a number, it can copy the number to the output, it can reset the number like this. Yes, it resets. Pretty optimized, I think. Well, I guess I'm just rambling at this point, but, well, if you want to solve this puzzle by yourself, be prepared, because it took me a week, and I also quit playing this game multiple times and came back to it multiple times. So if you want to solve it, make sure that you have a lot of free time, a lot of patience, and you might be a little bit insane, or you will get a little bit insane. I don't know it. And also there is a very good guide on Steam that has very helpful tips, and there are also like tracing of all of the programs, so that you can debug your solution by looking at this, and there are a lot of helpful tips. Well, I guess check it out, and that's about it. Thank you all for watching.